Hi everybody, welcome back to my project channel. Well, in my last video, I kind of showed that this transformer that I had in mind, let's see if we can get that in focus. Yep, well, it's upside down. This one was a little bit underpowered. You can see how it's a little bit yellowed on the back, right? That's because it's been around for such a long time. And this transformer here is it's got two 6-volt taps, and each tap it's probably delivering only in the order of 125 130 milliamps, which in my previous video I've tested and showed that that didn't work, so I couldn't really proceed. But today we have this guy, right? And this is a newer transformer. It's the same family. You can see how it's actually, well, let me kind of move it here, right? How it's a little bit larger. Well, the good news is that the pins, if you look at the spacing, they're actually matched, right? So other than the distance between the primary and secondaries being slightly, the actual spacing of the pins are the same, which means that I can just plug it into my board and I can have it work without actually doing too many changes. All right, so what we're going to do now is we're going to actually put this transformer in so that we can get the rest of the project testing to see whether this works. So this video we're going to do a bit of that. We're also going to be looking at some other testing of the board to see if our peak detector works. I have some ideas about what we can be trying to improve the thing, and in fact I've done quite a lot of work on the code this couple of days, trying to chase down some of the bugs and why I was getting some resets with the ESP8266. So we're going to look at that and hopefully get some interesting progress in this video. All right, let's get on with it. I originally had this board set up so that this transformer will go right in here. Now, if you look at this, the primary is split into two 120 volt coils, which you can kind of join the middle so that you get a 240 volt primary. So I made provision for this, but this is how it was supposed to go into the board, like so, right? And then underneath the board I had sort of marked out where it came. I had to make a jumper there for the primary, and then the first set of 6 volts would actually power the circuit. The secondary 6 volt secondary output is where I measure the voltage to get an idea of what the primary voltage was. I had put this in place here just so that I can do some testing and feed some DC, but heretofore I have not actually powered this off the transformers for the reason that we had. So now this was how it was going to look, and I got lucky because although this didn't work, this new transformer that I had, the pins actually line up quite nicely, so I could do this. I lose just a little bit of space. It still looks all right. It's quite a bit heavier, but if you look at it, that looks all right. Maybe a little bit tight around the capacitor, but other than that, it looks like it could work. So let's see if we can get that in focus. All right, so this looks like it could work. So what we're going to do is we're going to solder this transformer into place, and then we can we can see where this gets us. All right, so I need to, I should probably put this up here. Get this soldering iron out. And I'm not sure how interesting it is for people to see some soldering at work. I may have to break some more of these copper strips just to keep the isolation a little bit better. I'm not terribly comfortable with the idea of running mains on strip boards like this. Okay, so we get it in place. Okay, so that's done. All right. So what you have is this secondary goes right into the bridge rectifier, which then goes right into this. There's very, very little space around there, which I guess I probably should remove this now, I suppose. Oh, I don't need this anymore. This was just temporarily put in place so that I could test the board before I had the transformer in place. All right, so just clean that up a little bit. Okay. That looks nice. Okay, so we're gonna hook up some power to the mains. Now what I normally do is I have a tool here, a Vero tool. It basically looks like let's see if we can get this in focus. Or it looks like a drill bit. As a matter of fact, it's just a drill bit with a handle. And so what I do is I stuff it in here, twist it, and it seems to do the job quite well. So I had broken off some tracks here just to prevent accidental, I guess, prevent accidentally shorting out with other things. Not absolutely necessary, right? So what I'm going to have to do is I'm going to have to put some wires from here and then hook it up to mains. Now what kind of wire am I going to use? I think I'm going to just put some bare wires, but I really shouldn't do that because it's dangerous and I don't have an isolated transformer, but well, I'm impatient. So this is out. Now this guy is in. We shall see if this thing works. By the way, this transformer is supposed to be quite good for this sort of thing. It's short circuit proof and isolated. So if that gives you any consolation, right, 230 volts. Well, our primary is 240, 46, 45 volts in actual measurement, so that your output here may be slightly overrated, which is a good thing. Okay, so I'm gonna go away, and when we come back, we should have some wires on this. I'll see you back in a bit. All right, I've soldered the wires to the board, and just a simple connection at the back here. So I've put it down here to keep the whole thing stable. This is something I got off Banggood. If you're interested, maybe I can do a short review of that. It's really nothing much to see. Not a terribly good one, but it gets the job done. So the whole board is here, and I'm going to power this thing up now. So you should be able to look at the LEDs here, and you might not be able to see, but there's actually an LED on the RTC board on this side here. Okay, here goes. 3, 2, 1. All right, no smoke. LED is on, and that is a good thing. So I'm going to measure the voltage now. So let's get the voltage on DC. Let's check the voltage and see what we have here. 4.998. That's actually pretty good. That's actually very good. Let's check it to this point. 4.998. Yeah. So that's good. We are getting voltage, but let's just see how clean that voltage is. So we're going to go to the scope now. So let's see, what do we have? Okay, so right now we have this scope. It's AC coupled. So we're going to, let me just turn this cursor off, right? I've got it connected to channel 1. Let's get the scale up a little bit. Where is my probe? Okay, let's find the probes. Okay, let's put a probe onto this thing, and then let's get something going down here. Okay, so now we have voltage. It's AC coupled. We just want to look at the noise, all right? We know the DC is DC, but let's just look at the noise. Let's get the sensitivity down until we see something. No, I think we need to go way, way down. Okay, now we're looking at some spikes. So on that scope, you can see we have this occasional spikes, and they are quite large. So let's put the cursors roughly, I guess. It looks like maybe we're getting quite large spike levels. Let me see what happens if we increase the see what it looks like down in several milliseconds. Okay, so there's quite a lot of spikes on this power rail, so I'm not too happy about that. Let's see if I can just maybe just add a peak-to-peak measurement. Let's see, what do I want? I want a peak-to-peak measurement. This, I guess, is yeah, I guess that's what I want. So let's see about that. Okay, let's see. Oh, sorry, I didn't do that. Do that again. This thing sometimes takes a while to add measurement, hit OK. So now get rid of this. Okay, so we have this reporting a peak that goes as far as half a volt almost. Based on what I'm looking here, the actual extent of the things, the delta is just about 466 volts, maybe slightly, almost half a volt. So that's not good. That means that we're going to actually have to add some more decoupling, I hope. I'm guessing that most of the spikes are actually coming from the ESP8266. So I'm going to do that. I'm going to first of all, I'm going to power down the circuit, but you can see, by the way, that the LED is blinking, right? So not sure if you can see that, but it's not so clear. Let me get this lights off. Maybe with this you can see more clearly that it's actually blinking, right? So that's good. It's working, it's talking. The code is running quite well so far. There are still one or two problems I need to solve, but we're going to put some more decoupling caps on this thing. I'm going to disconnect this from main so that I don't accidentally kill myself. Okay, so that's all disconnected. We're going to look at maybe adding more decoupling, probably, I guess, somewhere between here. This is 3 volts between these 2 bits. I'm going to add more. Okay, so more is good, I guess. All right, we'll be back once I've done that. So we are back at the board. As you can see, I went a little bit overboard with the decoupling. I've got a 10 microfarad capacitor here on the 5 volt line, right on the other side of. You gotta keep this decoupling close to the where the point is drawn. Okay, so another 10 microfarad here. These are really small caps, and I hope the voltage rating is correct. I got several 0.1 microfarad caps down here, and I think this is a 2.2. I have a 100 picofarad here for the high frequency components. Down here I've got another whole string of decup. So I really went overboard with this thing, and I figured since I have all these caps lying around, I might as well put them to good use. So this is how I actually put this on this thing. Just gonna pull it back, and okay, well, that looks about right. Okay, just make sure nothing's touching on the bottom. All right, so we're going to power this up. I'm going to put it back on the mains, and let's hope nothing blows up. Okay, good. The lights are on. No smoke. I have to be careful not to touch this bit here because that's live. So what we're going to do now is we're going to put back the we're going to look at trace and see if we have any improvement over what we had before. All right, so let's get that in there. I'm actually measuring it right where the power goes into the ADC, which is actually where, wow, look at the trace. It's cleaned up nicely. Well, okay, I spoke a little bit too soon. It appears that when Wi-Fi is kicking in, well, I suppose the Wi-Fi bits is really consuming power. I'm still getting the same spikes before Wi-Fi is connected. So let me just reset this thing. Okay, I'm going to reset this. So now the board is coming up, right? So it's, as long as the LED is not blinking, there's no connection yet. So right now it's attempting to get a connection. It's probably got a connection now, but it's not sampling. That's right, sampling is what causes all those spikes, because now it would have been connected. Well, it seems to be taking quite a while to synchronize the. Once it starts blinking, that's when active sampling is taking place. But right now it's just waiting for the clock. I hope that is what it is. There you go. So it start blink. The moment it starts blinking, which is to say sampling is going on. So maybe the ADC is taking more power than I expected. So does that mean I should put even more capacitance on that line where the ADC goes. Let's see, should we do that? Well, if it's worth doing, it's worth overdoing, I guess. All right. Well, that's more. Okay, I'll get back to you. All right, more caps in place. Several other ceramic capacitors underneath, but not sure you can see this, but I've got like a small electrolytic that's 47 microfarad in place. Usually electrolytics have low ESR, so that could be the thing, you know, keeping the ESR low. So with that in place, let's hope that the signal, oh yeah, let's power this thing up first. Always a little bit of a scare when you turn this on, because you don't know if something might explode or you might get electrocuted because something changed that you did not pay attention to. Okay, so we've got this in place, okay, and let's just wait for the connection to come up. It's still there. Well, it does, I don't know, it looks like it might be a little bit less severe to me, but honestly, I think that's all I'm going to do about it. I'm going to leave that alone. Actually, why don't I look at where the power supply is elsewhere? What does it look like elsewhere? Say, what does it look like here? You know, it's interesting because it appears to me that if I probe the power supply at this point here, right, it's actually quite clean. I mean, compared to what we were looking at before, if I probe it, say here, which is where the power goes into the ESP8266, that is surprisingly clean. I mean, you do see a couple of little artifacts from where it draws power, but here is where it's actually kind of noisy. I suppose that might be due to the power drawn by the ADC itself. Okay, well, I'm going to leave that there. With, you know, this video is getting quite long for this part. I guess in the next part I'm going to do actual testing. I'll be running this offline, and we'll come back once we get a bit more results for this thing. And until then, you have a good one.